Leveraging my summer break, I had a 2-month internship in a research department of Huaxi Securities. My job focused on industry research, multi-factor stock selection, and industry momentum modeling. Using Python, I designed and executed experiments using CNN for factor analysis and backtesting. CNN is commonly used in computer vision research and applications, but considering that it can perform automated feature extraction and feature dimensionality reduction based on the data and labels, with the end-to-end and backpropagation properties of neural networks, its excellent properties can provide new methods for stock return modeling for us. Stock factor data can be organized into two-dimensional pictures, which gives CNN the ability to analyze time series. For the factor image of a certain stock, it is then input into CNN for convolution operation. This operation essentially involves factor synthesis of historical factor data, where different factors are multiplied by weights at the same time interval and accumulated to obtain new factor values. Next, the convolution kernel will perform convolution operations on the factor image in both horizontal and vertical directions, ultimately generating a convolution result image. I also participate in the dynamic improvement of the industry sentiment-driven model. I reduced the impact of covariance on the model by classifying and calling previous mesoscopic factors, while abandoning the modification of the model by ad hoc sparsity methods such as lasso to face the impacts of high-dimensional data head-on. At the same time, I use a rolling window approach to dynamically improve the industry sentiment-driven model with a view to incorporating the model to be compatible with the latest data and ultimately to significantly improve the forecasting effects of the model. At the same time, by digging deeper into the actual impact of each factor, I analyzed the main sources of the current industry sentiment gap while validating the logical foundation of the model. This project pushed me to think creatively about how to apply machine learning techniques to financial data. In quantitative finance, the ability to innovate and adapt cutting-edge methods to solve complex problems is highly valued. My experience with CNN for factor analysis demonstrates my capacity to leverage advanced tools to improve financial modeling and prediction. Financial data is often high-dimensional and noisy, posing significant challenges for traditional models. By using CNN for automated feature extraction and dimensionality reduction, I gained hands-on experience in managing these challenges, a skill that is directly applicable to cognitive finance roles where robust data processing and models are essential. Participating in dynamic improvement of the industry sentiment-driven model further enhanced my understanding of model refinement and adaptation. By using a rolling window approach and addressing high-dimensional data challenges, I learned how to make model more responsive to new data, a crucial skill for maintaining the relevance and accuracy of financial models over time. This internship granted me first-hand insights into the financial industry, particularly technology-driven innovation, the rise of quantitative investment, and the integration of fintech and traditional finance. I aspire to further explore the quantitative investment strategies.